Hey Tube, welcome back. Problem number 136, single number. We given a non-empty array of integers called nums. Every element appears twice except for one. We need to find that single one. You must implement a solution with a linear runtime complexity and use only constant extra. So we need to have like O of n, and we need to have like O of 1 in space time. So there is no recursion, and we cannot use as well nested loops. So how we can do this one? The previous video we did solve this problem in XOR, and in today's video we will in this video we will solve it in list. So how we can do that? We can just create a list. We can create a list, and we add the numbers to it, and we go like for each number. If the number, for example, we start with 2, if the number is not in the list, we add it. And we go to the next number, we find it 2 as well. So we find if the same number, if the number exists already in the list, and if it was, we delete it, and we continue looping, and we find 1 is not in the list, so we add it. And after that, by the end of the looping, since only one number is has no duplication, has nothing at all, it's only on a single number, we have only one, so we will return the first element. How this will be done, let's do it like easy one by one. First we can just create a variable called var no duplicate list, and it will equals no, not like that. And this one equals an empty array. Next we will create a loop. Okay, so this array will be used to store numbers that have appeared an odd number of times. Next we will create a loop. So for var I of nums. This loop goes through every number in I in the nums array. We create if statement if no list of that includes I. So here we saying that if I is not in the duplicate list, it means this is the first time we're seeing it, so we add it to the list. Okay, so we add it to the list. How we do that? We just push it. Next we use else. So else else if I is already present in the no duplicate list, that means it has appeared twice, so we remove it from the list using the splice method. So let's just copy this one and dot splice and again dot index of, of it's with bigger O, that index of I and 1. Yeah, that's it. And after that we need to return the first element in the no duplicate list. Let's run and see if it's working. It works. Submit. It works. Okay. So since every duplication number cancels itself out, the only number left in the in no duplicate list at the end of the single at the end is a single number that appears only once. We can do an example for that. Let's just do like, let's assume the numbers, the nums array, we have 1, 2, 2, and 1. So if we're trying to understand what's going on, first we have the first iteration, which will be I, and I will be in the beginning, so I will equals 2, and we add, and we then the node duplicate list, we add 2 to it, so we have 2. In the next iteration, I will still equal 2, and we find that 2 is already present in the node duplicate list, so we remove it, so the array is empty. In the third iteration, sorry, I equals 1, not 3. I equals 1. So the node duplication list doesn't have 1, so we add 1, and that's it. So we return the first element, which is 1. We can do the same exact thing with like bigger one, like 4, 1, 2, 1, 2, something like that, in order to understand it even better. We can do it like in like that here. So in the first iteration, you find that I equals 4. Okay, so we add it to the node duplicate list, so we have 4. In the second iteration, I will equals 1, and actually there's no 1, so we add 1 as well. In the third iteration, sorry, I equals 2, so we add 2. In the fourth iteration, I equals 1 again. So since 1 is already present in the duplication list, we remove it. And in the fifth iteration, I equals 2, and since 2 is present, we remove it as well. So we left with 4, and we return 4. So this is how it works. Okay, so this is a quite efficient solution to solve the problem. It's the second way to solve this problem, and yeah, that's it for this problem, and see you guys in future videos.